Hi everyone, this is the lab demo for liquid-liquid extraction. I'm going to perform the entire experiment for you. All you need to do is take notes and write up a lab report based on your notes in this video. Along the way, I'm going to pause to ask questions. Make sure you write down these questions and answer them in your lab report to get full credit. The purpose of this experiment is to separate a mixture of two solid compounds, benzoic acid and naphthalene. Both of these compounds are highly soluble in diethyl ether, an organic solvent, and both are relatively insoluble in water. However, benzoic acid is slightly more soluble in water than naphthalene because of its carboxylic acid group. Now, when you react benzoic acid with a base and deprotonate the acidic hydrogen, you're then left with a negatively charged benzoate anion, which is much more soluble in water and now is insoluble in our organic solvent. Naphthalene, on the other hand, will not react with our base and will stay as a neutral molecule. Thus, it will stay in our organic solvent and will not move into our aqueous solvent. Alright, first question. What is the solubility of benzoic acid in water? And what is the solubility of the benzoate anion in water? Here are the materials we'll be using. First, our glassware. A centrifuge tube, where our reaction and separation will take place. Our small test tubes for measuring out solvent. Erlenmeyer flasks for extracting our separated phases. A vacuum flask for filtering our solid from the aqueous phase. And a beaker for an ice bath. For our chemical reagents, we of course have our mixture of benzoic acid and naphthalene, our diethyl ether, which is the organic solvent, 3 molar sodium hydroxide, which is used to deprotonate the benzoic acid and will also be our first aqueous phase, 3 molar hydrochloric acid for then reprotonating our benzoic acid, and finally sodium sulfate for taking out any excess water left behind in our organic solvent. I'm going to go ahead and weigh out 300 milligrams of our mixture into the centrifuge tube. As you can see, I folded the weigh paper so that it forms a sort of funnel. So all of my compound will fall into the centrifuge tube and I won't spill any. Alright, the exact weight is 336 milligrams. That, again, 336 milligrams. I'm now going to place this into the centrifuge tube with 5 ml of our organic solvent. I already have the solvent measured out here, so I'm just going to pour it in. You can see there's a solid down at the bottom. I'm just going to shake this around until it dissolves. Alright, now that the solid has dissolved, I'm going to add 5 ml of our 3 molar sodium hydroxide. You can see now there's a little bit of a separation going on. I'm going to gently shake this around, keeping it open, so that the gas produced between our acid-base reaction of the benzoic acid and sodium hydroxide doesn't get trapped in this tube. I'm also going to cap it and shake it a little bit more violently. If you want to see what that looks like right now. You can already see some separation occurring. I'll get back to you when this is done. All right, question number 2. How many grams of sodium hydroxide does it take to create 100 ml of 3 molar sodium hydroxide? All right, the separation looks complete. Here you can see that faint line between the bottom and top, the line's like right here. My next question for y'all, what is the top layer and what is the bottom layer? Like, where is my aqueous phase and where is my organic phase? As a hint, look up the densities of diethyl ether and water. The more dense liquid will be on the bottom. All right, I've labeled my Erlenmeyer flasks 1 and 2. Number 1 will be the bottom layer. So I'm going to extract using this pipette. All right, all that's left in here is the top layer. All right, after extracting the bottom layer into this Erlenmeyer flask, I'm gonna cool it in an ice bath. While that's set aside, I'm gonna pour my organic layer into the second Erlenmeyer flask. Now, there's going to be a little bit of water in my organic layer. So I'm going to take out that water using what's called a desiccant, which is our sodium sulfate. The sodium sulfate will absorb that water without dissolving into the organic layer. I'm just going to add a couple scoops, shake it around, and wait about 10 minutes. You can see it's not dissolving. That's what we want. All right, now that the aqueous layer is cooled, I'm going to add about 5 ml of 3 molar hydrochloric acid, just to neutralize that sodium hydroxide from earlier. I'm going to go ahead and give this a stir, make sure it's mixed in thoroughly. You can see now the benzoic acid is starting to precipitate out. I'm going to go ahead and check the pH at this point using pH paper. You can see here, there's a color code to the pH paper, with the blue side meaning you're more basic and the red side meaning you're more acidic. Another question for y'all. How many milliliters of 12 molar HCl is needed to make 100 milliliters of 3 molar HCl? You can see this color I'm getting is orange, which corresponds to around pH 3 or 4, which is pretty acidic. That acidity of around pH 3 or 4 tells me that likely all of my benzoic acid is in a protonated form. I'm just going to add a little bit more hydrochloric acid to make sure all of the benzoic acid is protonated. Again, look how much more cloudy this solution is now. I'm going to go ahead and set up the vacuum filtration for this. All right, I've got my vacuum flask set up here. As you can see, it's connected by this hose to this water system. The way the vacuum is drawn is that this flow of water continuously draws a vacuum from this line. I'm going to fold a piece of filter paper just so it fits snugly into this funnel, and also to increase the amount of surface area we have of filter paper to our liquid. So that's how it looks. I'm just going to check real quick that the vacuum is working. And I can feel a vacuum. I actually can't even get my hand on it. Now I'm going to filter my product from the aqueous layer.
You might not be able to see it, but there's some dripping occurring here. Our water's getting sucked down.
Here's what it looks like up close. See the water dripping, and our solid is still within the filter paper. While that's going, I'm trying to capture some of this leftover solid that we have so we can increase our yield. I'm just going to use some cold water to get it out. And I'm going to go ahead and rinse this with a little bit more cold water. While I'm filtering out the benzoic acid, I'm going to go ahead and decant my organic layer. By decant, I mean I'm going to pour out this liquid while leaving all of that solid sodium sulfate at the bottom. Alright, I'm going to set this onto the hot plate to evaporate all of the organic solvent. And we'll just wait from there. As you can see, the benzoic acid is mostly filtered out. So I'm going to go ahead and take this out and dry it with some paper towels. Alright, I folded up the filter paper a little bit. I'm just going to squeeze it dry. I'm going to move it around the paper towel to like a new dry spot each time. Alright, I've squeezed out as much water as I could. Now I'm just going to let this air dry for a bit before I take the mass and melting point. So next question. Why is it important that we make sure our solid is fully dry before weighing and measuring melting point? As you can see, the benzoic acid is now dry, as well as the naphthalene. So I'll go ahead and weigh those and show you the melting point. Alright, we got our benzoic acid here. Looks like we got 26 milligrams. The mass of naphthalene collected, 90 milligrams. Now we're doing the melting point. On the right is naphthalene, and in the center is our benzoic acid. You can see the temperature is around 50 Celsius right now, and we don't see any melting occurring. We're at about 76, 77 Celsius right now. You can see the naphthalene on the right is kind of compressing a little, but not melting yet. We're at about 79 Celsius. You can see the naphthalene starting to melt. It's currently at 80 Celsius. The naphthalene has now melted at 90 Celsius. You can see it's still pretty solid. Looks like it's starting to melt at the outer edges. At 121 Celsius. The melting's coming along nicely now. We're at 123 Celsius. Melting's almost complete. And that's it. Melting's complete at 125 Celsius. And as always, don't forget to wash your hands. Just to recap, we separated a mixture of benzoic acid and naphthalene using liquid extraction. This was able to work because both benzoic acid and naphthalene are soluble in our organic solvent, diethyl ether, and both are relatively insoluble in water. However, when we react benzoic acid with a base and form the benzoate anion, we get a more soluble version of our benzoic acid, which then separates into the aqueous layer, leaving our naphthalene in the organic layer. When these liquids are separated, all we need to do is push our benzoate anion back into benzoic acid by adding HCl, causing it to precipitate or crash out. From there, we filter out that benzoic acid as its more purified form. For the naphthalene, all we need to do is evaporate our diethyl ether solvent, after drying, of course.